Hey, what's going on, folks? It's Mike here, and welcome back to the Deep Programming Language series. In today's lesson, we're going to be looking at the unit test feature again, but more specifically talking about what it means to write a good test. And we'll specifically look at the Deep Programming Language and some of the features that we have, although these are things that are applicable in all of software engineering. So with that said, I'm excited to talk about testing, and let's go ahead and get into it. So as a brief recap, if you didn't see the last episode, go ahead and check out documentation and the language reference. Go ahead and scroll down, and eventually we'll find the unit test feature here and give that a click here. And here it is, just a simple unit test block here. But there's a little bit more to this about how to write good tests. So I want to go ahead and talk about how we know if we've written a good test and the different types of tests that we have available. And then in the next episode that's coming up, we'll also talk about things like coverage of testing. So stay tuned for that and stay subscribed. So with that said, let's go ahead and take a look at some of the things that we've learned about the Deep Programming Language specifically that are very useful. So you'll notice here attributed unit tests here. So that means we can use things like @safe, for instance, or @system or @trusted to write our unit tests. In fact, we can use other attributes and things like no throw and pure, which are going to make our tests even better. So we'll go ahead and start taking a look at some of these features here. Let's go ahead and play around with some examples here. And I'm just going to go ahead and write a simple function here. Let's go ahead and write a function. I'm just going to call it sum here. It'll take two arguments, A and B. It'll add them together. And we're going to follow the best practice by adding our unit test block after it. And then let's go ahead and give this a try here. So what I want to go ahead and do here is use assert, for instance, that the sum of 2 and 3 is equal to 5. I can say 2 plus 3 equals 5. And let's just go ahead and make sure that this is working here. And again, I'm going to just run this with DMD unit test. We have a main function. If you don't have a main function, you can run with -main, and it'll generate one if you're just doing one module at a time. And our main file here. And let's output this and call this program. I'll run it, and we see that this test passed here. Okay, so far so good. Now, what could be kind of interesting here for us to do is to, again, make sure that our unit test is a pure function. So for instance, let's go ahead and add the pure attribute to the unit test. Let's go ahead and rebuild, recompile, and that's very good. That means we don't have, again, with the pure attribute, any sort of outside state that's getting modified. So for instance, let's say I have this global function here, or global value here, and let's set it equal to 5, and let's do global plus plus. And let's go ahead and sneak that in here. We are going to have a problem here, okay? And again, what pure is doing for us is ensuring that we don't have any state that's getting mutated in a test here. Now, why that's important, for instance, is because I might have this global value here. Let's go ahead and set it to 2. And let's go ahead and run our test here. Again, because it's being used in here, that's problematic. And why that's problematic, again, is because, well, let's go ahead and take out pure here, is what if I'm coming in this other unit test here and modifying things? I'll do global plus plus, and I'll go ahead and compile this. I'll run. And the issue is, depending on how these tests are running here, I might actually kind of break this test here. In fact, let's see if I can break it here. Let's make these equivalent here. Global plus plus. I'll compile it, run it, and we're getting these failed unit tests here again. Okay. Actually, I think the first instance might have failed as well here. Just didn't catch it here. Yeah, failed here. Again, in the next one of the next lessons here that's coming up, I'm going to go ahead and give you a little bit more power so you can see exactly which unit test is failing here. But if I had had the pure on each of these, right, we can see that, you know, as this value gets mutated here from outside state, could be something that has nothing to do with our unit test, for instance, that is just a problem here. So we do want to put pure on our unit tests here. Okay, so that's going to be the first lesson here. And then it will, of course, capture that we can't modify this state here. Okay, so let's go ahead and just fix this up here. And now our unit test will pass. Okay, so that's sort of a best practice number 1, using pure for our unit test. The other thing that I want to go ahead and make available to you, or terms that you should know, is Whitebox versus Blackbox testing. So let me go ahead and give a sort of view of this. idea, and we're going to go ahead and write a little function here. Again, just to practice some of our D skills. Let's get a little bit of exercise here, some more repetitions in. And we're going to write a function here that's going to return a bool, and we're going to call it my is sorted function. What it's going to go ahead and do is take in a list of integers. I'm just going to call these, let's just call this array for now because it is an array here. And it's going to return true or false if this array is sorted. And we're going to keep it simple. It's just going to be in ascending order. So let's go ahead and write a loop here. I'm going to say for, let's make it a for each loop here. And let's go ahead and say for each element in array. And well, how do I write the is sorted here? I could do this in a few different ways with D. Remember, I can have a index variable here. Let's just go ahead and write things out here for a moment here. Just to give you a reminder, index, I'll put a bar here and then the element, just in case you haven't seen this in a while here. And let's do my is sorted. And I could just put in some slice here, something like this. And let's do one that is not sorted, something like this. Okay, and we need to turn off our unit testing because I actually want this to run here. Oops, I've got to return a value here. Let's just return a true for now, as I'm just sketching this out here. And let's run it again, just so you can see that we could use these values here. So if I want to check if this is sorted or not, what I'm going to go ahead and do here is have a bool and the result. I'm going to assume false. That is not sorted here. And we basically just want to search if each of our elements is less than the upcoming element. And I realize it might be a little bit easier to just use a for loop here. We could get the index, and then we could also create a slice here. Whoops. From, let's go ahead and set this up here. From 0 to $-1 or something like this, right? Just to again show you that we could look through things, but I don't want to exercise our that's just not as intuitive in my mind to write things. So let's go ahead and say for the index idx less than array dot size, and let's go ahead and just check if the array at idx is greater than array at idx plus 1, then we'll go ahead and return our result. Okay. And we can think about if this is going to be greater than or greater than equal to, if we want it to be monotonically increasing for the sort. That's sort of up to us here. And I need to do a -1 here. Okay, so let's go ahead and otherwise, let's see, make this even just a little bit more simpler. Let's just get rid of our result here. This will be return false. Otherwise, we will return true if we look at everything and it's in order. Okay, simple enough little sort function there. So, what is it? Size. Sorry, I always get these mixed up here. Length. And oops, I don't have I have idx. There we go. Try to make it a little bit more explicit here. And if we run this, we could go ahead and see our values here by putting in a little right line here. And actually, let's go ahead and, let's just go ahead and write our unit test here. And what I want to go ahead and do here is let's go ahead and assert that this is going to return true. This is sorted. And let's go ahead and assert for this one, this is not sorted. Okay, so we want to say or negate this, right? Because we could clearly see 1, 2, 7 is a problem here. And let's go ahead and compile this. Let's compile it with the unit testing so we get that code running. Let's see here. Oops, again, sorry, a little off by 1. There we go. Compile it, run it, and we are good to go. So we do pass everything. Now, there's a little subtlety here with this unit test function here. And the whole point of us writing this here was, would we also consider something like this to be sorted here? Okay, this is sorted here. Now let's go ahead and compile this with our unit tests. Let's go ahead and run it. And, well, this appears to be the case that it's sorted, right? Because if I'm looking at the next value here, this is only returning false when this value is greater than. Okay, so 2 is not greater than 2, it's equal. So if it's less than or equal to, we will eventually return true here. So this is an example, and let me go ahead and write out here. We have knowledge of the source code, so we can write a test to it. So for example, or I should just say, we call this Whitebox testing. Maybe it should be called like Clearbox testing or something of that nature, but the basic idea is that we can see into the actual code and write a test for it to test that functionality because we have this knowledge here. Now, what I want to go ahead and do here is, on the other hand, show a black box test here, okay? So I'll go ahead and put under this unit test, again, Whitebox test. I own the implementation or source, so I can write a test to it. A black box test, on the other hand, so that's going to be over here, black box test means I don't have any idea of the implementation, okay? Now, where could we get a black box test? Well, let's go ahead and just look at the D standard library. Now, I know we can't actually find that code, but let's again just pretend we have no idea. And let's go ahead and look at their version of is sorted here. So I'll go ahead and have to search here. Let's go ahead and open up a new tab here. Is sorted. And there is an algorithm for it here to look at a range. And we can see some of the different versions of it. And again, there is a sort of strictly monotonic version that doesn't allow for duplicates. And there is a just is sorted version that does allow for it, okay? So let's just work with the is sorted one for now and come back in our code here. I'm going to go ahead and paste this in. And let's go ahead and make sure that this works. Now I am going to have to include a library here. Let's see if the D tells me. Yeah, it doesn't tell me what I need here. I need to import standard range, I believe. And again, with our unit test blocks, just like with any code in D, we can scope our imports to the curly braces. Okay, so let's go ahead and bring that in. Up is sorted. Let's see, what is it? An algorithm. Import standard algorithm. Oops, and make sure to save. There we go. Let's get rid of this if I don't need it. Perfect. And I go ahead and run it, and everything passes. Now, if I go ahead and, black box test means I should write a few more edge, cases to be sure I understand how it works. Okay. So again, this is just more of a software engineering thing to keep some of these ideas in mind, that I probably want to write or use this example here. So something like this here. Let's go ahead and write, all the different edge cases that we could think of. So 7, 5, or 4, 2, 25, 29, dot is sorted. That is not sorted, right? So we want to go ahead and check that. And then we probably want to just try a trivial example of like 1, 2, 3, something like that here. Okay, so I have no knowledge of the implementation here unless I dig into the library, which of course you can do or find on GitHub. But that's the basic idea with the black box test here. Okay, so hopefully that makes sense. And usually you have an advantage with the white box test, but it makes it that much more important for you to write assertions for the different edge cases that you might find. Again, sort of a trivial sort here where there's repeats, and one example where there's not sorted, for instance. So testing all those edge cases. You can try to do that for your black box and your white box test, but for your white box test especially, you can find some corner cases. Now, a few other things here that I want to go ahead and show you. And we haven't talked too much about exceptions yet in this series, but that is coming up if you can see the theme here that we're talking about testing now. And I just briefly want to show you that the other thing that you can do here is remember you can still check if an exception is thrown. Okay, that is something that you can assert in the D programming language. So let me go ahead and just write a function called thrower, for lack of a better name here. And what that's going to do here is it's going to throw a new exception. Okay, and I'll just call it exception, thrown here. And I might want to check that that exception is actually thrown and handled here. Okay, so let's go ahead and try it out here. First, let's just go ahead and put thrower in our unit test block. Let's see what happens since we haven't looked at this. And we are probably going to have to bring in the exception module here. Let's see if we get an error here. Oh, I guess it worked. Yeah, we get a giant exception thrown here at line 45 and a whole bunch of information here. Okay, so that's telling us, yeah, our unit test failed here. So how do I capture this? Well, we have assert thrown. Okay, let's see what happens if I wrap that there. And again, this is where I'm going to need to, I believe, bring in exception. And then we're good to go here. And now if I run this, our unit tests pass here, okay? Because you want to be able to check if you have error handling code that error handling code, in fact, is being caught here, okay? So just a little note here on something else that you can do with the unit test blocks that's going to be very valuable. Okay, and let's go ahead and take a look here. I want to go ahead and show you one other thing that might be interesting for you to know about with unit tests here. And let's go ahead and just write a function called compile time here. And basically what I'm going to do here and say if CTFE, and basically that means that, let's go ahead and write a pragma here for message and ran at compile time here. And let's go ahead and say else write line ran at runtime. Okay, there'll be a runtime function. Let's go ahead and compile this. You can see that we have the piece of code that ran at compile time here. And just to make this a little bit more interesting here, let's go ahead and make this an int, and it'll return 42 if it runs at compile time. Otherwise, it'll just return 0 here, okay? Now, this is a little bit of an advanced case, but it's okay. We're in our second video on unit tests. But let's write a unit test here. And what we're going to do here is assert for compile time that when we call this function, it returns 0. So the runtime version. And let's go ahead and do the static assert here. And this is going to be the compile time version. Okay. In fact, the way I usually think about these is one after the other here. And let's go ahead and just see if this is caught here. Okay. And I'll explain what this underscore CTFE thing is here, because we haven't really talked about that. Let's go ahead and compile this. And immediately, okay, it is going to throw this assertion here. I mean, this is just getting caught here in the unit test here. But let's go ahead and just make this 42. Make that a little bit bigger for you. Let's go ahead and give this a run here. And it's good. It runs at compile time. Now, this is an interesting test here because what underscore CTFE does, and I'm probably going to do this in another video and probably like the same exact example, but it'll be a good refresher. This is the block of code that runs at compile time. So you can think of this like as a separate function for whenever we're able to execute this function at compile time. This is the block of code that runs at runtime whenever we have a function that's just running at runtime. The decompiler is smart enough too, you won't pay any cost for this if-else block or this check or anything, right? You can think of these as like two separate functions that are generated effectively. But my point here in regards to unit testing is we still sometimes want to have the static assert for maybe we have a compile time version of our function. Maybe we just have a regular function that runs at compile time. So this is a little bit of an extreme one, but I'm testing the same function for its compile time behavior and its runtime behavior. So again, a little bit of an advanced concept here, but it's an interesting thing nonetheless that we can do with the deprogramming language. Okay. All right. So with that, I'll just put a reminder. Check your function's compile time and runtime behavior. Don't forget about static asserts, okay, in your unit tests. Okay, perfectly fine to have static asserts in your unit tests. Again, those follow the same rules as they always do, or they run at compile time. Okay, so a brief recap. This is a mega lesson on unit tests, but hopefully a useful one. Again, to write your asserts. But let's see, our first lesson, let's go ahead and just number this here. Number 1, use pure whenever possible, okay? That should probably be a default for unit tests, but again, you can explicitly put it there. And make sure that you're not having outside side effects, because if you have multiple unit tests, for instance, you want to make sure they're usually running in isolation. Our second tip here, let's go ahead and do this, is tip number, how am I labeling these? Number 2, here, I'll just go ahead and put number 2, understand Whitebox testing. Find, holes in your implementation, okay? Because you can actually see the code, so you can test it a little bit more rigorously, okay? For Blackbox testing, number 3, try to test as many edge cases as possible. Okay, that was our Blackbox test. Number 4, don't forget that you can also assert if an exception should have been thrown. Test your error handling code, or test that your error handling code actually gets called. Okay, perfectly valid to do that in unit tests. And number 5, here I'll put it by the unit test here. Don't forget about compile time and runtime behaviors. Okay, a little bit of a new thing here. We'll have a dedicated lesson to it later on, and you'll already have seen this before here. Okay. Alrighty, folks. So with that said, this is a monster lesson on unit testing. Hopefully you enjoyed it. Hopefully it helped you out here. As always, you can check out the course, the rest of this course here, available on YouTube or my site, courses.mshot.io, so you can track your progress and make sure that you see all the other unit testing things that come up. And of course, there's other goodies and courses here that you can explore here. Alright, folks. So with that said, I'll go ahead and end it here. Thank you for your time and attention. Hopefully you're learning a lot about testing and enjoying it. It's a super important part of software engineering, but again, it's a reason why I really like the deprogramming language, because it lets me think like a software engineer, not just somebody who's writing code, but how to actually test that code and build correct and functional software. All right, folks, with that said, again, we'll see you in the next lesson.